All right, welcome back. So in this particular video, we are going to build a proper RAG end to end. And in this one, we are going to cover many different topics. So we are going to create a separate repo just to make sure that the things don't get messed up very easily. So far, we have been using this particular notebook, right? What I'll do is whatever I've used so far, the sample PDF, the image, when we were trying to understand what is multimodal AI, all of these I'll put along with the chroma data also. I'll delete this chroma data. We don't need it. Delete permanently. Yes. What I'll do is I'll create a folder called rough work. Let's throw all these. Okay, cancel. Let's throw all of these into the rough work. I don't think it will allow me to do. Okay, let me do that manually. No, it went. Okay. Okay, everything is inside of rough work. Now let's start building our repository properly. So to understand and build this RAG properly, I'm going to use L&T website and I'll extract information from their website and I'll use that as my vector database. So we are going to create the vector database using information present from L&T website, but not just the official website. I'm going to use multiple different URLs. We'll be doing some web scraping and then we'll be reading some PDF files. And then we are going to create a data set out of it. To get started, there are few URLs that I was able to capture. Let me take you to one of them. So this is one of the URL. Just a second. I'll put it in a Jupyter notebook here. Or let's go with main.py. So here you can see these are the URLs and I'm going to extract the content from these URLs and I'll put the content in this text file. And these are all the PDF URLs and I'm going to download these PDF documents. If I take you to any one of these, you can see this is an actual PDF document, their annual review 2024. And this is a 39-page document. It has lots and lots of information, including the CEO name, chairman, and managing director. So there are many different things here, right? So we are going to extract all of this information and we'll be storing this also in a text file. So for website, we'll read it, we'll take the text and we'll put it in a text file. For the PDFs, we are going to parse the information, then we'll put it in the text files. So for every single information, for every single URL and for every single PDF, I'll have a separate text file created. Okay. To do that, we will need two different functions. So let's create a utilities folder, or I'll say utils. Inside of utils, I'll say parsing utils.py. Now, inside of parsing utils, let's create one function, this one, save web pages as text. So here I'm using request library and beautiful soup library. I'm taking the URLs, okay, all these different URLs, not the PDF, okay, only the top ones. I'm going to take only this set of URLs and I'll pass them here. For URL and file item, I'm going to take the URL separately and file name separately. These are key value pairs, okay? This is key. This is my value. This is the URL. This is the file name. So URL and file name are here. I'm going to use my request library to call that URL, and I'll take the response.text. I'll send it to my beautiful soup. I'll parse it using HTML parser properly. Then I'm going to take the text. This is going to be a string. I'll write the string into a file. What is this file? This file will be in datasets folder with the file name. Where is this file name coming from? It is coming from the URLs dictionary, which is this one. So which means for the first URL, if you see this one, larsenturbo.com/corporate/about LT group/overview, whatever I have inside of this URL, I'll read everything. I'll paste it in this text file. I'll write it to that text file. And I'll repeat the process for every single URL. This is the whole purpose of this function. That is the whole purpose of this function. So we are handling this top portion. Let's do the same thing for the PDFs also. For PDFs, we have one more piece of code, which is this one. So over here, I'm using PyPDF again. So I'm taking the PDF URLs, URL and file name. I'm taking the path. I'm putting it in a separate variable. Then I'm replacing the .pdf with .text. If you observe carefully, all the values in the first set have .txt. But here I'm going to save them as .pdf. Sorry, I've written it as .pdf. Later on, I'll be converting and I'll be reading and I'll store everything in a text file. But for now, I'll pass the file name as .pdf. I'll tell you why. So here we have PDF underscore file path, text underscore file name, text underscore file path. These three different variables. Now keep these in mind. This is for one URL. Okay. Now keep these in mind. Next, step one, we will download the PDF, which is this part. So using the PDF file path, I'm writing it. This is why I need the .pdf name. If you see, this is PDF file path. Before changing the .pdf into .txt, I'm storing it in this variable. I'm passing it here, which means whatever I'm reading will be stored into the .pdf file. Next, successfully downloaded the PDF file. Next step, we need to extract everything. To do the extraction part, whatever we have saved before, we'll read it again. And this is reader, and I'm using a one-line code, what do you call it, list compression, to combine everything into this extracted text. This extracted text variable now has, it is basically a very giant string of all the text I've got inside of the document. I'm saving it to my text file, which is after replacing the .pdf with .txt. So now there are two files created. One is the PDF file, second is the text file. Two-step process, right? In the first function, I'm saving everything. I'm reading, I'm saving directly. But here I'm downloading, then reading, and then I'm saving. Here I'm using PyPDF, but if I want to make it much more robust, then I can implement document intelligence also for this. Okay, so I'll take all of the text file. I'll take all of the data. I'll put it in my text file, say successfully extracted and saved text from PDF. Done. So these are the two different functions that I'm going to use to parse all of my data. So let's go ahead and run them. But to run them, keep in mind, okay, this has to be at the top. Okay, keep in mind that the first function has to receive only the top set. The second function has to receive this bottom set, the PDF URLs. I can also store these in separate dictionaries and I can pass them, but I want to create a third function which will properly handle everything. And that function is this one. It's very simple function. I'm importing both of these, which I don't need, but in the process text files, I'll pass everything. Now here I'm going to separate that into two different separate dictionaries using dictionary comprehension. So if the URL is ending with a .pdf, it will go into PDF URLs. But if it is ending with a, if it is not ending with a .pdf, then it will go into web page URLs. Structure will remain the same, okay? The URL as the key, file name as the value. Now I've got two different dictionaries. I'll pass the PDF URLs dictionary to download and parse PDF function, which is what we have observed so far. So I'll download the PDF, I'll parse everything, I'll save it into text file. Now the web page URLs will be passed to the first function, the save web page as text function. And in this one, I'm going to read all of the content. I'll read it using Beautiful Soup. I'll paste it. I'll write it to a text file. Simple. So I need to call this function with all of my URLs. Let's go ahead and do that. In the main.py, I've got my URLs. I'll put the imports at the top. Function name, copy. And in this one, let me collapse this actually. From utils.parsing utils import this function. Then I'll call this with the URL file mapping dictionary. So when I run the main.py, this will automatically read all of this content and it will save everything into text files. I've already done that part. So let me show you how that actually looks like. Yeah. There you go. So in the data sets, you can see everything has been downloaded and they have all been parsed properly. So let's take a look at this one. Larsen Turbo overview.txt. Here it is. And you can see all of that information has been parsed, whatever we have in that website. Let's double check with the very starting itself. We have overview L&T Corporate India, overview L&T Corporate and L&T India. Let's go to that URL. We have overview. Where is L&T Corporate? Media, contact us, investors. Media. Okay, there you go. Media, contact us, investors. Group websites is also here. L&T group websites, corporate Arabic, L&T group websites. Okay, it must be hidden somewhere. Let's take a look at the paragraph that I just saw. Yeah, this one. Larsen Turbo is an Indian multinational engaged in EPC projects. Larsen Turbo is an Indian multinational engaged in EPC projects. So we were able to read the content of this and paste it in a text file. Similarly, I was able to create different text files for all of them. But you can already observe the problem here. There are a lot of gaps, a lot of unnecessary things. For example, the same overview about L&T, all of this is just basically noise, right? Unnecessary information. There's nothing information or there's no data in these kind of noisy chunks, noisy lines. We're going to clean all of that in a few seconds. Okay, so far we have processed all of the files, right? Now let's go ahead and create chunks out of these files. So to create the chunks, I'll create one more utility called chunkutils.py. Okay, so in the chunking utils, we are going to use the recursive character text splitter. Mm, First, let me. Okay, I'll go with this function first. We are importing the recursive character text splitter. We are taking the text that we are reading from the text file. So let's assume the first one. I'll be reading all of this text. I'll store it in a variable called as text text, and the file name from which I read it, and the actual URL from which I obtained all of that text. All of that will be passed to this process text function. Uh, Let me import regex. Okay. Now I'm doing some basic cleanup, very basic cleanup actually. Just lower everything and then I'm removing the consecutive two spaces, consecutive two new line spaces. Then I'm using the recursive character text splitter with the chunk size as 5 and 2 and chunk overlap as 32. What this is going to do is it will take all of this information. Whenever there is a consecutive two new lines, it will remove them. This is also two consecutive new lines. So essentially it is going to convert everything into like this. Or if I have to give an example, it will convert it into like this, where every line has some text at least. So after doing that part, we are going to split everything into chunks. We'll take all of those chunks and we'll store them in this list. So I'll write a simple for loop on this chunks variable. For each chunk, I'm appending a dictionary into the chunks data list. So by default, it will be empty. So in the for loop, for every iteration, I'm appending this dictionary inside of it. This dictionary has two keys. First key is chunk data, which is the actual chunk, the small text, the sentence. Next, we have metadata. Metadata is one more nested dictionary where I've got the file name and the URL. So to store this metadata, I'm passing both of these things here. If not, I can just ignore them also, not a big issue. But to have that as a metadata properly, I've kept it here. So this is one function to handle one text file. To call this function, I need a for loop where I'm reading every text file and I'm passing the text, file name, and the URL respectively. So let's go ahead and create one more function where we are doing exactly that, which is this one, chunk data. So we have URLs. We have a empty list here called all chunks data. So whatever chunk data it is returning for one file, I'm going to store them in I'm going to accumulate all of them and I'll put it in this all chunk data array in this list. Okay, so URLs is pure. I'm not doing any splitting or anything. It has both the PDF versions and the web URLs combined. I'm passing it here. And if the file name ends with a .txt, then I'll implement this logic. There's I missed out small piece. Import JSON. Import should be at the very top always. There's a small mistake here actually. We should not check it with this ends with condition, but rather if file name ends with .pdf, file name is equal to file name dot replace pdf with .txt. Yeah, this is correct. Okay, so we are iterating through each item in that URL's dictionary, and then for each file, we are going to read the file first, the text file. Then we will pass the file name, the URL, along with the text. So we are reading it here. So we are storing it in text variable. I'll pass it here. File name and URL variables are coming directly from the key value pairs of this URLs. I'll pass all of them to the process text function, the first function. This will return me the chunk data. So this is going to be a list. I need to accumulate all these lists, right, for every file. So what I'll do is I'll keep on adding them into my all chunks data. Keep in mind, I'm not appending, I'm adding, which means this empty list plus like 1, 2, 3. So if I do this one, let me put it in a different notebook actually. ARR is empty. ARR.append 10 is different. This is different. Okay, both of these are two different things, right? And this is also different. I'll say VRR equal to this. All these three are completely different things. Just give me a second. Let me connect properly. So in the very first one, if you see, I'm appending an element, an integer to an empty list. So this will become an element. But in the second one, the element itself is one more list. So list inside of list. That is what we are doing here, which is very wrong. We don't want to do that. We are going to extend the list. We will just add more items to that list. Yeah, if you see the difference here, appending 10 as an integer, or I'll take BRR equal to 10. Yeah. So if you have this as an integer, then you can append it directly. But if you have it as a list, yeah, if you have it as a list, then you need to extend it. Plus is equal to, which is what we are doing here. So this chunk data is a list, right? We are appending everything and we're storing that in a list. So we need to accumulate this list. So that is why we are going to extend it. Now all chunks data, by the end of this for loop, it will have chunks of each and every single file. Whatever text file we have, it will have chunk data of every one of them. Then I'll write everything into this JSON file, json.dump, all chunks data, and indentation is 4. So let's try to see how it looks like. I'll put it in the data set itself. Yeah, this is how it is going to look like. For each file, we have created n number of chunks. So you can see this chunk was created using this file name, using this URL, and this is the actual chunk content. Similarly, I've extracted for every single text file, right? So let's create the pipeline where we did that. I'll say in the main file, I'll say from utils.chunk utils import chunk data of URL file map. Oh, sorry, this is supposed to be utils. Yeah, there you go. Now it is in nice colors. So we are reading everything, we are processing all of the text files, then we are chunking everything, and then we are creating these small chunks out of all the files combined. Okay, there are 1255 lines here. This is the JSON, and we are going to take all those chunks and we are going to store them in our ChromaDB. So let's see how we can do that. So to do that, we have to create the embeddings. Let's start by creating the models first. What I'll do is I'll rename this one into parsing.py, and I'll put both of them in run parsing function. So which means whenever I call the run parsing function, it will call this first one and then the second one, right? Now in my repo, I'll say main.py parsing import run parsing. Run parsing is one step. For now, let's comment it because we have already created the JSON file. Let's create one more called creating vector database.py. So in this Python file, we are going to store all of our functions related to creating the actual embeddings. So let's start by importing our sentence transformers. Then we are going to create the embedding model. So we are going to use the same embedding model again, all mini LM L6 V2. That's a mouthful, but this is such a powerful and free model. You can run it directly on your CPU machine also. Okay, so this is my encoding model. Now we need to create ChromaDB. So let's import ChromaDB also. And we are going to create a collection instead of this ChromaDB. And then we'll be storing all of our chunks into this ChromaDB. Again, I'm going to use persistent client. So let me create the client. And I'm passing the name as this one, LNT RAG ChromaDB dot slash. Yeah. Okay, so this is my persistent client. And I'm creating a collection with the name of LNT collection. Okay, I'll save this one. We need to insert everything into this collection also, right? To insert it, I've created this one more function. Let me paste it here. Okay, so this function will take the JSON file name along with the model and the collection. What is the model? This model, the embedding model. What is the collection? This one, the ChromaDB collection that we created. So we have to pass both of these into our function. So let's go ahead and do that in the last line. So I'm calling the function. This is my JSON path. So dataset slash all chunks data.json, dataset all chunks data.json. This is where I have everything. I'll pass the path here, model and collection. Now inside of this function, let's see what we are doing. Okay, first it's a very simple print statement. Then we are reading everything using JSON.load, and then chunk data, dividing it into sentences and metadatas, two separate things. Then for sentences, I'm using model.encode and I'm creating the embeddings. I can ignore this step completely because, as I told you before, ChromaDB will use the same model. The all mini LM L6 V2 model is the exact model that ChromaDB is using in the backend. So I can go ahead and ignore this part completely and uh, give a correction and pass sentences here. Yeah, I can do this as well. But for simplicity's sake, let's just keep it as it is. I'll say model.encode of these sentences. I'll take the embeddings. Then for into the collection, I'm going to add all of these embeddings because collect, every chunk needs a separate ID. I'm using enumerate. So enumerate of index, and the index should always be a string value. ChromaDB indexes will not accept uh, integers, floats, or other data types. It has to be a string. Okay, so in this function, I'm reading everything in my JSON and I'm pushing everything into my ChromaDB, right? So let's put all of this in one more function called add to ChromaDB. Run add to ChromaDB. Let's put everything inside of it. I'll be importing this function in my main.py again. I'm creating VDB, import this function, and I'll call this function. Now, what happens when I call this function? Let's see. I'll comment both of these. Now this will create a persistent client, which means it will create a folder here. It will read all those chunks. It will convert them into embeddings. It will store everything in those embeddings. It will add everything into that collection. All of that will be done in one go. There you go. Preparing 179 chunks for embedding generation, generating embeddings using sentence transformer model. Let's give it a couple of seconds and it should be done. Successfully created embeddings, and there you go. Everything has been added into ChromaDB. And here you can see LNT RAG ChromaDB has been created. It has collection and it has the SQL-like database also. So everything is already here. This main.py is done. I can also implement, I should have done this already. So I can use this piece of code to check if everything has been added properly or not. But you can see it in the print statement, right? 117 have been added. Okay. Now let's go ahead and build the very first component of the RAG, which is retrieval. So let's do one thing. It's getting a bit clumsy here. I'll create a folder called components. I'll put both of them in my components. Now there are too many folders here. So what I'll do is I'll create a SRC folder. My components and my utils both will go into the SRC. My rough work, obviously I have to delete this one later, but for now I'll just keep it here. Dataset is, it has to stay outside because I'm reading everything from the dataset. Okay. Now In my SRC, I'm going to create something called re- uh, retrieval.py. I'll put it in components. Or actually, let's keep it in the SRC itself. It'll be easy. So in the retrieval.py, we are going to paste this simple piece of code where I'm passing the embedding model, which is the same sentence transformer, all mini LM6v2 model, and my ChromaDB collection. I'll pass my query and the top K value. What this is going to do is it will take the query, it will convert that into embedding, then it will do the collection.query using this embedding, and it will fetch the top K results. Exactly how we did it in the FAS index. We are doing the same thing here. We are creating a query vector. In this case, it's an embedding, and we are passing that and we are searching it in our collection. There are many other things that you can do in this part. You can do filtering based on metadata also, but for now, I'm not doing any of that. I'm storing the output in the search results. Then I'm putting everything in a nice list where each item is a dictionary and it has three different keys. Each dictionary has three different keys: document, metadata, and score. The score is nothing but the distance, and metadata is the actual metadata that we originally captured, like the URL file name. And it will return all the relevant queries. So this is very simple, but we can make it slightly more robust by introducing something called as query re-ranking. So re-ranking is a technique where you will use some sort of a math function. In this case, we are going to use cross encoder, but essentially you can use many different functions also. So essentially what you'll do is you'll use a math function to create one more score, and you'll reshuffle all these items based on that score, so that whatever you're retrieving, you're doing one more filtering on top of it where you're getting rid of unnecessary things. You're keeping only the relevant ones. And also the order will also play a very important role. So whatever chunk is the most relevant one is going to be at the top, and the least relevant is going to be at the bottom. So this is a very simple piece of code. So it is going to take the cross encoder function, embedding model, the collection, query, and the top K. And I'm going to call the first function inside of this one. Okay. So whatever question the user is asking, I'll pass it here along with top K. And the collection that I've created, this one, the LNT RAG ChromaDB has one collection, right? This one, I'll pass it here. Then my embedding model, all three will go here. This will get me the top results. Now I'm going to create one more key called cross encoder score. For this cross encoder score, I'm going to calculate it like this. Very, very simple. Then I'll be returning it after sorting, and I'll take the top K. I'm doing list slicing here. So let's say if this gives out 5 results and if my top K is 3, obviously it won't work that way because even for the query ChromaDB also we are passing the same top K, but still this is like a double security. I can make this as +5, and whatever the top K we have here, the top K values will be returned, and these are re-ranked results, which means they have been reshuffled properly such that the most relevant one is in the first index, the second most relevant one is in the second index, third most relevant is in the third index, etc., etc. So these are two different things on how we can retrieve content from the ChromaDB, whatever vector database that we created. So let's go ahead and use this one. I'll put some import statements at the top. Let's import our embedding model. This one, sentence transformers. Next, my collection from ChromaDB. This is a persistent client, right? So I can use the get or create. Next, I'll use my cross encoders. Okay. This is the cross encoder that I'm using. L6v2, MS Macro Mini LM L6v2. Both of these are compatible with each other. That's why I'm using them. Okay, now let's pass all of these along with the question, who is the chairman of L&T? Okay, it's very simple, right? So I'm passing all of these along with my question to the query and re-rank function. It will go here, it will get the top results plus 5. It will do the re-ranking. It will give me the uh, sorted results, and I can print them here. Sorted results equal to this. Okay, perfect. Now let's go ahead and put all of this in our main.py because these are retrieval components. From src dot retrieval import variant read and chroma db. Yeah, there you go. So all of this is set. Parsing is done. Adding everything to chroma db is also done. Now let's go ahead and query this. And this is our relevant content. I'll simply print the relevant content. Now let's go ahead and run the main.py and see the output. Okay, so it fetched me all this relevant content. Let's see. Mm, Retrieved final 3 most relevant content items after re-ranking. This is the first one. It has the chairman, Nayak, Mr. Nayak, uh, Mr. Harsh Mariwala. Okay, we have the name somewhere in this one. Okay, so we were able to retrieve the relevant chunk. Okay, there you go. L&T's chairman and managing director, Mr. A.M. Nayak. We can see that here. So our relevant content is ready to be sent to LLM model. Now it's just very simple task where we have to connect to Azure OpenAI and then we have to send this content over there. Let's go ahead and do that as well. If you remember this part, we are loading all the environment variables. We are connecting to Azure AI client, and this is my prompt. Who is the chairman of L&T? Let's put everything in a nice format. I'll put all the imports at the top. I'm loading all the environment variables. This is my prompt. Now I'll take this relevant content. I'll put it here. My prompt will go here. Okay. And whatever content I'm going to get, I'll attach it to my prompt to create the enhanced prompt. This one. To create this enhanced prompt, I'm going to attach it. But for simplicity's sake, I'm not going to write all these return format warnings and everything. I'll just put the goal. I'll keep the content dump, only these two. So attached content is this one, whatever I've fetched. Okay, now let's go ahead and send both of these to my LLM model and then we can print the output. You are a helpful assistant. Use the attached content if needed. That's it. And this is my prompt. Let's go ahead and run all of this. There you go. The chairman of Larsen and Turbo is Mr. A.M. Nayak. This is what the LLM has answered. But you see how much time it took to do the retrieval part, the augmentation part, and generation is very quick, of course. We are paying for the API. But for the retrieval, it took a lot of time. So this is kind of like a drawback that you're going to get whenever you're working with completely local environments. So what I would suggest is if you're building a production environment, if you're building a production project, then we can go for cloud-based services. For reading the document, we can use Azure Document Intelligence. And for storing everything in a vector database, we can use Azure AI Search. For retriever also, it's way more powerful. And there are many different filtering methods and many different configurations that you can implement instead of Azure AI Search. Finally, for retrieving the relevant content, Azure AI Search is very fast. Then for generation, of course, we are going to use Azure OpenAI. So these three services combined will help you build a very powerful RAG with very less setup. So this is how we can set up a RAG backend. I hope you guys learned a few things in this, what is 47 minutes of course. In the next lesson, we are going to learn what are the different problems that you'll face whenever we are building a RAG. And with that, we'll be able to complete the RAG module and we can finally jump onto the agentic AI. If you have made it this far into the video, thank you so much for watching. See you in the next one.